guys, welcome back to another video, and today we'll be discussing about Bayes' theorem. So I'm trying out a new paper. Let's see how it looks. So moving on to the whole theorem. So this is the whole equation that we'll be working on. So P what we are looking for is the probability of A happening given that B. So this sign, the straight line, this represents given. So how do we find this? So the first thing that we are looking for is the probability of B happening if given A, then multiply with probability of A and divided by the probability of B. So to understand Bayes' theorem, we need to understand these four concepts. So these concepts represent different situations that might happen, and we will look into these situations when we are doing an example. So let's say someone has cancer, right? So this is this side, like the left side, this represents someone having cancer, and the right side represents that what they are what's the test results, right? So false positive, that means that you don't have cancer, but you are tested positive. So that's never good, right? You don't have cancer, but the doctor tells you that the reports say that you have cancer, so that's never good. So false negative, so you don't have cancer and the test results say that you don't have cancer, so this is good, this is what we want. So and true positive is similar, so you have cancer and the test results are also positive, so that person has cancer and he has been properly diagnosed with it, so which is not good, but it's better to identify it at the early stages, right? So this is kind of what we want. And finally, you have cancer, the person has cancer and is tested negative. So this is like one of the worst things, because you already have, that person already has cancer, but is tested negative, so he has to live with it, and things might get worse later on. So these are the two things that we don't want in any situation whatsoever. So let's try to look into a question, an example, and see how this comes into play and how Bayes' theorem helps us to understand real life situations. So this is the question that we will be working on. So the question I collected from Patrick GMT. It's a YouTube channel, you can look it up. It's pretty good for anything mathematical related. Anyway, so the question says approximately 1% of women aged 40 to 50 have breast cancer. So there are a lot of statistics here. I don't know if they're correct or not. Moving on, a woman with breast cancer has 90% chance of a positive result. So if the person has cancer and the test is positive, so it's there's a 90% chance of situation being that, while a woman without has a 10% chance of a false positive result. So the woman doesn't have cancer, but the results say she does. So there's a 10% chance of that happening. What is the probability of a woman has breast cancer given that she had a positive test? So what the question is asking for is that the test results are positive. However, we want to know that does the woman actually have cancer or not? So the thing that we are trying to find out is basically this. So P, the woman has cancer and she has been tested positive for it. So this is what we are looking for, right? So according to Bayes' theorem, so the situation would be, so she is tested positive for cancer given that she actually has cancer, into the probability of the woman having cancer divided by the probability of the test being positive. So in your classes or in the examples, you might see that they just put values and try to calculate it. However, I'm going to follow a tree structure, which is like much easier to understand what's happening. So this is the main situation. This is like our starting place. From this we would have two situations. So one where the person has cancer, and this is the person doesn't have cancer, right? So what's the probability for that? So this says there's 1% chance of women aged 40 to 50 have cancer. So this is 0.01%, 0.01 chance of a person having cancer. So it's 1%. So 1 divided by 100 is 0.01. That's why written that. And there's a 99% chance that the woman might have cancer. This is a not sign. So moving on. So what can happen from here? So there would be two situations. So the situation is that the person is tested positive and the person is tested negative. And similarly, from this place we would also have two situations. The person is tested positive and the person is tested negative. So what are the values here? So according to the question, so a woman with breast cancer has 90% chance of a positive result. So this portion, this is basically the person has cancer and there's a 90% chance of them having this. So 0.90 and this would be 0.10. And while a woman without, so we would be looking into this portion here, without has a 10% chance of a false positive. So this means that this portion means that the woman doesn't have cancer, so but it's still tested positive. So it would be 1% and 10. So 0.10 and this would be 0.90. So let's try to find out what would actually happen. So if we put values up in the equation here, we would get the answer that we're looking for. So first portion says that the woman has cancer, is tested positive and actually has cancer. So we'd be looking into this branch. So the person so let's try to highlight this. So this is what we're looking for. So the person does have cancer and is tested positive. So let's write the equation, write the values down. So it would be 0.90 into 0.0.1. And below that we have the probability of the results being positive. So this would be this situation and this one. So let's write them down too. So one would be 0.01 into 0.90, the same thing that we have written above, plus, and this case, so 0.99 into 0.10. So the result would be, so this is the final result that we are looking for. So this means that the probability of a woman who has breast cancer and is given positive result is 8.3%, which is actually really good if all the statistics given here are actually true. So you have cancer and you have been tested positive is 8.3%. So it's actually good that in a sense that you have there might be situations where you don't have cancer but you're tested positive, so it gives you a lot of hope. Also this results can also represent something bad. Anyway, so rather than looking at that, so this is how Bayes' theorem works. I hope you guys did understand this whole thing and how it works, and if you have any questions or suggestions, feel free to comment down below. Thank you.